You hear black holes swallow everything. Light, matter, time itself. Nobody comes back. 1 billion times the mass of our sun compressed to nothing. Darkness so complete it warps reality. But here's what nobody tells you. The strangeness begins before you even reach the edge. Your time, their time. 2 different universes. Information that might survive, radiation that shouldn't exist, and a paradox that broke physics for 50 years. Stand at a safe distance. 100,000 kilometers from a 12,000 solar mass black hole. Not the supermassive beasts at galaxy centers, not the stellar corpses 10 times our sun. Something in between. Your spacecraft engines burn just to hold position. Gravity here pulls at over 1,500,000 meters per second squared. Green light shifts to yellow, 550 nanometers, stretches to 560. Time already runs differently. 59 minutes for you equals 1 hour for Earth. You're on the clock, and it's already slowing. Send a probe inward, 30,000 kilometers per second, 1/10 light speed. The craft glows orange against the void from your perspective. Redshift from velocity. At 100,000 kilometers from the event horizon, it darkens. Deep red. 600 nanometers stretched to 650. Gravitational redshift now dominates. Your instruments switch to infrared. 50,000 kilometers closer, the probe vanishes from visible spectrum. Mid-infrared, far infrared. At 10,000 kilometers, it appears to slow. Not because it decelerated, because time itself bends. 30 seconds for the probe. 1 minute for you watching. The craft seems to move at half speed. 3 days you wait. The probe hovers 1 kilometer from the event horizon. 23 minutes pass for the crew inside. They see your 3 days flash by in less than half an hour. Light from your ship blue shifts into X-rays, gamma rays. The universe outside speeds up, but they don't feel it. Their clocks tick normally. Their hearts beat the same. Relativity doesn't care about your perspective. It just is. If you value documented astrophysics and cosmology history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the Astrophysical Journal Letters, published in October 2024 by the LIGO-Virgo-Cagra collaboration documenting gravitational wave events, and from research by Sarah Isaun at the Harvard and Smithsonian Center for Astrophysics, published in Space.com in December 2024, analyzing magnetic fields around Sagittarius A star. These aren't popular science summaries. These are peer-reviewed observations with event designations and collaboration rosters. Now back to the information. 1 meter from the horizon. Time dilation goes infinite. The probe would see centuries pass in seconds, millennia in minutes. Within the last 5 millimeters, wavelengths stretch to radio, to nothing. At exactly the event horizon from outside, time stops. The probe freezes. Light shifts to infinite wavelength. You never see it cross, not in your lifetime. Not in the lifetime of stars. This is gravitational time dilation, and it's real, measured on Earth. Confirmed in GPS satellites, clocks in orbit tick faster than ground clocks by microseconds daily. White dwarf stars show redshift in their light. The sun's surface shows it. This isn't theory, it's measurement. But the probe's crew crosses, they must. No barrier exists at the horizon. No wall, no fire. Not for a supermassive hole this size. They fall through in finite time. Their time. 23 minutes already passed when they turned back. Crossing takes seconds more. Inside the horizon. Still alive, still intact. For now. Stellar black holes, 10 to 20 times the sun's mass. Event horizons measured in tens of kilometers. The tidal forces there are different. Lethal before you arrive. Spaghettification. The term comes from Stephen Hawking in 1988. Your feet fall faster than your head. Gravity's inverse square law. At the horizon of a 10 solar mass black hole, tidal force on a 1 meter tall object equals the weight of 800 million kilograms, pulling your feet down. Your body stretches, atoms separate, electrons ripped from nuclei. 2 forces act, radial stretching from gravity gradient. Tangential compression, because gravity pulls toward the center. Not just toward a point below you, toward a point that shifts as you fall. Your width compresses as your length extends. Spaghetti. The math is Newton's law modified for distance. Tidal force proportional to mass divided by radius cubed. Small black holes have small radius. Big force. Supermassive holes have big radius. Small force at the horizon. A 1 million solar mass black hole. 3 million kilometer Schwarzschild radius. Tidal force at the horizon. 80 grams. The weight of an apple pulling your feet. You'd cross without noticing, until you fell deeper. The singularity waits inside. Point of infinite density according to equations. Infinite curvature. Where math breaks, general relativity predicts it but can't describe it. Quantum mechanics refuses to allow infinities. Something else must happen. Quantum gravity. A theory we don't have. Frozen stars, objects that never quite finish collapsing, alternatives to classical black holes proposed in September 2024, no singularity, no information paradox. No event horizon in the traditional sense, just quantum objects with bizarre properties, untested, unproven, but mathematically consistent. October 20th, 2024. LIGO detects gravitational wave event GW 41010. Two black holes merging, 2.2 billion light years away, 16 and 30 times the sun's mass. The larger one spins fast, unusual fast. The smaller one falls in. They spiral. Space-time ripples propagate outward at light speed. Amplitude measured in strain, 10 to the negative 21, a change in distance smaller than a proton's diameter across 4 kilometers. But we catch it. Triple detector. LIGO, Louisiana. LIGO, Washington. Virgo in Italy. The signal matches predictions. Einstein's equations hold. 1 month later, November 10th, 2024, GW 41110, 8 and 17 solar mass black holes, 2.4 billion light years distant. The larger one spins opposite its orbit, never seen before. Retrograde rotation, the merger produces a hum, musical overtones in the gravitational wave, because the mass ratio exceeds 2 to 1. Both events show something else. Second generation black holes, these aren't collapsed stars. They're black holes that formed from previous mergers, hierarchical mergers. The spin rates prove it, too fast for stellar collapse. Too aligned or anti-aligned. Dense star clusters drive these collisions. Globular clusters, stellar cores where black holes gather. Hundreds in cubic light years, they orbit, interact, merge, repeat. The products carry their history and spin and mass. Each detection confirms Einstein, confirms Hawking, adds detail. Another piece logged, December 2024. Astronomers publish analysis of magnetic fields around Sagittarius A star, the supermassive black hole at our galaxy's center. 4.2 million solar masses, 26,000 light years away. Event Horizon telescope images show organized magnetic field structure, similar to M87 star. The black hole in Virgo A galaxy, 6.5 billion solar masses, 53 million light years distant. Both holes show the same pattern, ordered fields threading the event horizon. But Sagittarius A star has no visible jet. M87 does. Twin jets, plasma streams millions of light years long, moving at near light speed. Powered by the black hole's rotation and magnetic field, Sarah Issaoun leads the research. NASA Hubble Fellowship Program, Einstein Fellow. She suggests Sagittarius A star might have a hidden jet, waiting to be observed, or recently shut off. The magnetic geometry is there, the engine ready, just not firing. Why? Unknown. Under investigation, rotating black holes differ. Kerr metric. Roy Kerr solved Einstein's equations in 1963, 47 years after Schwarzschild's static solution. A spinning black hole drags space-time, frame dragging, lens-thirring effect, space itself rotates. At the event horizon of a maximally rotating hole, space-time spins at the speed of light in the rotation direction. Outside the horizon lies the ergosphere, oblate region, touches the poles, extends to the equator. At the equator, the ergosphere radius equals the Schwarzschild radius, the non-rotating value. At the poles, it shrinks to half that for maximum spin. Inside the ergosphere, you must move. No static observers. Space-time drags you faster than light relative to distant space, but not faster than light locally. You just fall in the hole's direction. Forced co-rotation. Roger Penrose proposed extraction in 1969, the Penrose process. Drop an object into the ergosphere, split it. One piece falls in, one escapes. The escaping piece can have more energy than the original, 20.7% more in a single interaction. Repeat the process. Theoretical maximum approaches 29%. The black hole loses angular momentum, spins down. The ergosphere shrinks, eventually vanishes. The hole becomes static. This might power quasars, active galactic nuclei, gamma ray bursts. Computer models support it. High energy particles stream out. Observed jets match predictions. Energy extraction from rotation. Real astrophysics. February 2024. Astronomers discover a quasar. J0529-4351. Light travel time 12 billion years. The black hole at its heart weighs 17 to 19 billion solar masses. The brightest quasar ever observed. It consumes 1 solar mass per day. Gas? Dust, stars, anything close enough. The Eddington limit sets a theoretical maximum. Radiation pressure from accretion should blow away incoming matter. The limit scales with mass. This hole exceeds theory. It feeds beyond the Eddington limit. How? Unknown. Perhaps the inflow is clumpy. Perhaps magnetic fields funnel matter. Perhaps the limit doesn't apply the same way in the early universe. It exists. We see it. Theory struggles to explain it. November 4th, 2024, Noir Lab announces LID 568. A black hole observed 1.5 billion years after the Big Bang. James Webb Space Telescope spots it. Chandra X-ray Observatory confirms it. The hole feeds at 40 times the Eddington limit. Super Eddington accretion. The black hole gains mass faster than theory allows. Short-lived. This can't continue. But while it lasts, it grows explosively. This might explain early supermassive holes. Webb keeps finding them. Black holes billions of solar masses when the universe was young, too young for standard growth, starting from stellar mass. Accreting at normal rates? The math doesn't work. Super Eddington phases solve it. Brief periods of extreme feeding, rapid growth, then normal accretion. Repeat. Models show it's possible. Observations confirm it happens. Another mystery partially solved. April the 16th, 2024. Gaia spacecraft, data release, Gaia BH3. A stellar black hole in Aquila, 33 times the Sun's mass, 1,926 light-years away. Second closest black hole to Earth, the largest stellar mass black hole in the Milky Way. Gaia detects it through astrometry. A companion star wobbles, invisible object pulls it, period, amplitude, mass calculated. 33 solar masses, no light, must be a black hole. How does a star leave such a massive remnant? Metal-poor stars, hydrogen and helium only. They lose less mass during life. More material remains at death. Collapse produces bigger holes. Theory predicted this. Gaia confirmed it. January 25th, astronomers observed 2 black holes feeding on the same galaxy, 600 million light-years away. One black hole at the galaxy core. 100 million solar masses. Another black hole wandering. 1 million solar masses, located 2,600 light-years from the core. The wandering hole tears apart a star tidal disruption event. Spaghettification on stellar scale. Hubble images, the flash. Chandra detects X-rays. The debris stream forms an accretion disk. Half the star's mass falls in. The other half ejects outward. This light signature. At 2024, TVD. First optically discovered off-nuclear tidal disruption event. The wandering hole likely came from a merged galaxy. Its own core, now orbiting inside the larger galaxy. Eventually it will fall to the center, merge with the central hole. Billions of years from now. But we see the early stage, 2 holes, 1 system, both feeding, documented, confirmed. The information? Paradox, 1975. Stephen Hawking calculates black holes emit radiation. Quantum effects near the event horizon. Virtual particle pairs appear everywhere. Vacuum fluctuations, normal space. They appear and annihilate. Net zero. But near a horizon, 1 particle can fall in. The other escapes. Hawking radiation. The escaping particles carry energy. The hole loses mass. Over immense time, it evaporates. Completely. A solar mass hole takes 10 to the 67 years. Supermassive holes take 10 to the 100 years. Longer than the current age of the universe by factors beyond counting. But eventually, gone. Here's the problem. The radiation is thermal, random, no structure, no information about what fell in. A star collapses. You measure its composition. Iron core, hydrogen envelope, helium layer, specific mass distribution. It forms a black hole. The hole has 3 properties: mass, charge, angular momentum. That's it. All other information erased. No Hare theorem. Then the hole evaporates. The radiation carries no record of the star. The information is destroyed. But quantum mechanics forbids destroying information. Fundamental principle. Unitarity. Time evolution must be reversible in principle. Information preserved. Total contradiction. Black holes erase it. Quantum mechanics requires it. Both can't be true. Decades of debate. Camps formed. General relativists sided with Hawking. Information is lost. Quantum mechanics breaks at horizons. Particle physicists disagreed. Information survives somehow. Quantum mechanics holds. New physics needed. The paradox stood unsolved until recent years. 2019. Breakthrough calculations. Replica wormholes. Mathematical technique using extra copies of a black hole. Researchers at Cornell, Tom Hartman, Amir Tajdini, Edgar Shigulian, they calculate the Page curve. Don Page predicted it in 1993. If information escapes, the radiation's entropy increases, then decreases, follows a curve. The calculations showed it. Semi-classical gravity produces the curve, without invoking full quantum gravity. Additional effects ignored by Hawking. Gravitational configurations Einstein allowed. Quantum extremal surfaces proposed in 2014 by Netta Engelhardt and Aaron Wall. Like using statistical mechanics correctly for an ideal gas, not just average velocity, full distribution, the calculations work. Information leaks out in the radiation, gradually encoded, not obvious, but present. 2023, Xavier Calmette at University of Sussex, quantum gravity corrections, minuscule effects, but crucial. They modify Hawking radiation, make it non-thermal. Structure emerges. Information can encode. The paradox resolves. Quantum hair. Black holes aren't bald. Quantum corrections at the horizon store information, like static on a record, invisible at first, but there. The radiation picks it up, carries it away, slowly. Over the evaporation time, nothing destroyed. Unitarity preserved. Einstein and quantum mechanics reconciled, at least in principle. The math works. Observation impossible. Hawking radiation too weak. Black holes too cold. A solar mass hole has a temperature of 10 to the negative 8 Kelvin, billionths of a degree. No detector can measure it. We can't test this experimentally yet. But the theory holds. Multiple independent groups, different approaches. Same conclusion. Information survives. July 16th, 2025. Webb telescope discovers the Infinity Galaxy. Nicknamed from its shape. 2 compact red nuclei, each surrounded by a ring. Figure 8 pattern. Collision in progress. 2 disk galaxies merged head-on. Between the nuclei sits a supermassive black hole. Not at either center. In the middle, in a vast expanse of gas, Peter Van Dokkum leads the team. Yale University, Gabriel Brammer co-authors. University of Copenhagen. They proposed direct collapse. The black hole didn't form from a star. It formed from a gas cloud. Collapsed directly. Skipped the stellar stage. This might explain early supermassive holes. Standard process. Star forms, lives, dies, leaves stellar mass hole, millions of years. Then it grows, accretes, mergers, billions of years to reach supermassive scales. But Webb finds billion solar mass holes when the universe was young. Not enough time for standard growth. Direct collapse solves it. Gas cloud massive enough, dense enough. Conditions right. Collapses straight to a black hole. Thousands or millions of solar masses immediately. Then grows normally. Enough time now. The Infinity Galaxy might be our first direct observation of this birth of a supermassive black hole. Never seen before. Hypothesis to possible evidence. One step closer. September 29th, 2025. Black hole merger confirmation. Complete cosmic collision tracked. Einstein's relativity confirmed again. Hawking's predictions validated. The merger starts within spiral. 2 holes orbit. Gravitational waves radiate. Carry away energy and angular momentum. Orbits decay. Separation shrinks, frequency increases, amplitude grows, chirp signal, frequency sweeps upward, amplitude peaks, then ring down. The merged hole settles, like a bell struck. Oscillations, quasi-normal modes. Frequencies depend on the final mass and spin, all 3 phases detected. Compared to theory, match precisely. General relativity describes strong gravity, predicts these signals decades before detection. LIGO's first detection 2015. 100 years after Einstein published the equations, more than 50 mergers detected, since each one tests relativity. Each one confirms predictions. Some add new details, unexpected spins, mass ratios, distances. But the fundamental theory holds every time. If you appreciate documented discoveries presented with scientific rigor, subscribe. This supports research into making complex astrophysics accessible. Comment where you're watching from. This information comes from primary sources. NASA's James Webb Space Telescope official reports published July 2025, analyzing the Infinity Galaxy and direct collapse hypothesis. Physical review letters. Papers on quantum hair corrections to Hawking radiation published March 2023 by Calmette's group at Sussex. Not secondary summaries. Original papers with equations and observational data. Back to the science. May 8th, 2025. UC Berkeley announces rogue black hole discovery at 2024 TVD. the off-nuclear tidal disruption event. Yuhan Yao leads the research. The wandering hole revealed itself through violence. Star passes too close. Tidal forces overcome stellar structure. Star stretches, breaks, spaghettification. Debris streams both directions, half falls toward the hole, forms accretion disk, friction heats it. Temperatures reach millions of degrees. X-rays blast out. Optical light too. The flash alerts telescopes. Follow-up confirms it, not from the galaxy core. From the outskirts, the hole is wandering. This validates theory. Galaxy mergers leave behind holes, not always at centers. Sometimes they wander. Eventually they sink. Dynamical friction. They interact with stars, lose energy, spiral inward. Over billions of years they reach the core, merge with the central hole. But we catch some mid-journey. This is one. Direct evidence, photographed, measured, confirmed. The Zwicky Transient Facility finds it. Automated survey, Palomar Observatory, California. Scans the sky. Detects transients. Nearly 100 tidal disruption events since 2018, all from galaxy cores, until this one. This one is different, offset from center. Follow-up observation required? Hubble examines it. January 16th, 2025. Pinpoints location, 2,600 light-years from the core. Chandra measures X-rays, confirms black hole presence. Spectral analysis reveals the hole's mass, 1 million suns. The core hole is 100 million. They're close enough to eventually merge, not for billions of years, but the path is set. LISA will detect these. Laser Interferometer Space Antenna. Planned space mission. Gravitational wave detector. Sensitive to massive black hole mergers. Millihertz frequencies. LIGO detects stellar mass mergers. Kilohertz. LISA detects supermassive mergers. Different band, different sources. Launch planned for 2030s. This discovery validates the mission design. These systems exist. They will merge. LISA will hear them. Black holes curve space-time. Mass warps the fabric. Einstein's field equations describe it. Geometry responds to matter. Matter moves along geodesics. Straight lines in curved space. Planets orbit stars, not because force pulls them, because they follow space-time curvature. Freefall feels like floating. Accelerating feels like gravity. Equivalence principle. Foundation of general relativity. Near a black hole, the curvature is extreme. Geodesics bend sharply, light bends, time dilates, space contracts, all measurable, all confirmed. Gravitational lensing. Light from distant objects curves around massive foreground objects. Einstein predicted it. Eddington confirmed it. 1919, solar eclipse. Starlight bent by the sun. Measured deflection matches prediction. Modern astronomy uses lensing everywhere. Galaxy clusters lens background galaxies. Creates arcs. Einstein rings. Multiple images. Black holes lens background stars. Microlensing. Brightness changes as alignment shifts. This is how we find dark objects. Like black holes, no light emission, but gravitational effect visible. August 10th, 2025. Astronomers announce cosmic horseshoe. Giant Einstein ring, complete circle. Background galaxy perfectly aligned behind foreground cluster. The ring reveals a black hole. 36 billion solar masses, one of the most massive ever found. 5 billion light years away. The lensing geometry calculates the mass. Distribution of light constrains it. Modeling shows the central black hole, that massive. The ring confirms general relativity, tests gravity at scales beyond the solar system, beyond the galaxy, cluster scales, cosmological scales. The theory holds. Every test, every observation. Time passes. Black holes remain strange, not just extreme gravity, fundamental physics playground, where quantum mechanics meets general relativity, where information paradoxes appear, where time stops and starts depending on where you stand, where rotation twists space itself into new shapes, where energy can be extracted from emptiness, where singularities hide behind horizons we can never cross from outside, where the math breaks and new theories must emerge. The discoveries continue. Webb finds early black holes, LIGO detects mergers, Gaia maps wanderers, event horizon, telescope images, magnetic fields. Each observation adds detail. Each paper adds understanding. Slowly, the picture sharpens, but questions remain. How do the first supermassive holes form so quickly? What happens inside the horizon? Does the singularity really exist? How does quantum gravity resolve the infinities? What carries the information out in Hawking radiation? Can we detect it? Will LISA hear mergers across cosmic time? Are there intermediate mass black holes still hiding? How common are rogue holes between galaxies? What triggers jets? What shuts them off? The strangeness is real, not speculation. Documented, measured, photographed, gravitational waves recorded, spectra analyzed, masses calculated, distances measured, spins determined. The predictions of 1915 holding true in 2025. Einstein's math works. Even when it predicts things Einstein himself doubted, black holes exist, hundreds found. Thousands inferred, millions predicted. At the centers of most galaxies, a supermassive black hole sits, ours included. Sagittarius, a star, right there, 26,000 light years away. You can't see it. Too dark, too distant. But radio telescopes image it. Infrared instruments track stars orbiting it. 17 stars cataloged in tight orbits. S2 comes closest. 16 light hours at periapsis. Completes an orbit every 16 years. Orbital velocity reaches 7,600 kilometers per second. 2.5% light speed. The orbital parameters calculate the mass, 4.15 million suns, plus or minus 10,000. Uncertainty from measurement precision. Not from doubt. The whole is there. Confirmed beyond question. The strange becomes normal when you work with it daily. Astronomers discuss black holes like plumbers discuss pipes, masses and spins, accretion rates and jet powers, tidal disruption event rates and gravitational wave strain amplitudes. The numbers are real. The observations are documented. The physics is tested. But step back. Consider what we're describing. Objects where time stops, where space tears, where information might vanish or might hide in quantum fuzz, where you could orbit forever or fall through in seconds depending on your frame. Where energy comes from, rotation extracted through empty space, where stellar masses compress to points, where billion solar masses sit at galaxy centers, where mergers shake space-time itself, and we hear the vibrations billions of years later. Well, that's not normal. That's the universe revealing itself. Strange, beautiful, terrifying. True? Every number cited here is from published research. Every discovery has a paper. Every observation has data. This is documented reality. Not imagination, not science fiction. Astronomy, physics, mathematics applied to observation. The universe doesn't care if we find it strange. It just is. And we keep measuring, keep calculating, keep improving our understanding. Because that's what we do. We look, we think, we test, we publish, we refine, repeat year after year, decade after decade. The picture gets clearer, the strangeness remains, but we understand it better. October 3rd, 2025. Scientists propose ultra-high-energy cosmic rays originate from black hole winds. Norwegian University of Science and Technology team. Colossal winds from rotating black holes. Particles accelerated to energies beyond 10 to the 20th electron volts. Highest energy particles known. Computer simulations show it's possible. Penrose process drives it. Energy extraction from rotation. Particles gain mass energy equivalent, escape at near light speeds, travel across intergalactic space, hit Earth's atmosphere, create extensive air showers, detected by ground arrays, the source mystery solved. Perhaps another hypothesis. More observations needed. September 24th, 2025, rogue black hole detected beaming energy 230 million light years away. Dwarf galaxy, black hole displaced nearly a kiloparsec from center, not wandering. Ejected. Gravitational recoil, three-body interaction, or asymmetric gravitational wave emission from merger, kicks the remnant, escape velocity achieved. The hole leaves the galaxy, still accreting. Disk material trails it, jets fire. Radio emission detected. X-rays measured. The hole survives, departure, continues feeding. How common is this? Unknown. First clear detection. Survey biases favor central holes. Rogue holes are harder to find. No bright galaxy around them. Just the accretion signature. This one happened to beam toward us. Jet aligned. Lucky geometry. How many we miss? Calculation pending. The strangeness multiplies with observation, not decreases. Every answer raises new questions. But the answers are real. The questions are specific, not philosophical, testable. We're designing instruments, planning missions, writing proposals, allocating telescope time, taking data, publishing results. The process continues. Because black holes are accessible, not with spacecraft. We can't visit, but with light, with gravitational waves, with particles. They reach us, carry information, we decode it, build models, test predictions, revise and repeat. June 2025. Scientists use AI to analyze 12 million black hole simulations. High-throughput computing, machine learning algorithms, patterns emerge. Milky Way's central black hole characteristics predicted. Compared to observation, match, validation, the simulations work, the physics is correct, or at least close enough. Refinements continue, but the basic picture holds supermassive black holes at galaxy centers, influence star formation, regulate gas flow, feedback mechanisms, AGN winds, jet heating, interactions with galaxy evolution, coevolution. Black hole mass correlates with galaxy bulge mass, not coincidence. Causation, process still debated, but correlation is clear. Observation confirms it. Theory explains it. Simulations reproduce it. The science is solid, but the strangeness is real. Both true simultaneously. This is physics. Reality doesn't care about human comfort. It just exists. We measure it, describe it, predict it, test those predictions. They hold. The universe is strange, black holes especially. Time stops, space tears. Information paradoxes resolve through quantum corrections we can't observe. Singularities hide behind horizons we can't cross, but we can orbit them, image their shadows, detect their mergers, measure their masses, calculate their spins, track their motion, document their effects. And we do. That's the reality of black holes, not philosophical mystery. Physical object, described by equations, observed by instruments, measured in mass, spin, distance, luminosity. Spectrum, real as the ground under your feet, strange as time dilation and frame dragging and event horizons. Both aspects true, both aspects documented, both aspects active areas of research, with papers publishing monthly. Discoveries announced yearly, conferences held annually, students trained, postdocs hired, tenure track positions filled, facilities funded, missions planned, data archived, open access provided, peer review conducted, results reproduced. Standard scientific process applied to objects where time stops and space tears and quantum mechanics clashes with general relativity. That's black holes. Strange, documented, real. The observations continue. The discoveries keep coming. Each one adds detail. Each one tests theory. Each one confirms or refines our understanding. But the strangeness remains because it's built in, fundamental. Black holes are where physics pushes to its limits, where theories meet their boundaries, where new insights emerge, where the universe shows us what's possible, what's real, what exists even when it seems impossible. 7 decades after serious theoretical work began, 6 decades after Kerr solved rotation, 5 decades after Hawking discovered radiation, 1 decade after LIGO detected mergers, we're still finding surprises. Second-generation black holes with retrograde spin, super Eddington accretion in the early universe, direct collapse candidates observed, wandering holes caught feeding, information paradox resolving through quantum hair, magnetic fields organized around horizons, possible hidden jets waiting to fire, ultra-high energy cosmic rays from black hole winds, each discovery documented, each one peer-reviewed, each one adding to the picture. And the picture shows strangeness, not ordinary strangeness, fundamental strangeness, the kind that comes from the universe itself, from the way matter curves space, from the way time flows differently in gravity, from the way quantum mechanics and general relativity interact, from the way information encodes in radiation, from the way horizons trap light but leak particles, from the way rotation drags space and allows energy extraction, from the way tidal forces stretch and compress, from the way mergers ring and settle, from the way it all actually works. Observed, measured, confirmed, May 30, 2025. Intermediate mass black hole evidence accumulates. Series of studies, different methods. Gravitational wave detections, X-ray observations, dynamical measurements in globular clusters, the missing link between stellar and supermassive, hundreds to thousands of solar masses. Theory predicts them. Observation finally finds them. Not one. Multiple candidates, different mass ranges, different environments. The picture fills in. Black holes span 9 orders of magnitude, from 5 solar masses to 50 billion, all real, all observed or inferred, all following the same physics. Einstein's equations, Kerr metric for rotation, Hawking radiation for evaporation, Page curve for information. It all connects. One coherent picture, strange but consistent. January 2025. Scienceholic publishes analysis of AT 2019 QIZ. Tidal disruption event discovered 2019. European Southern Observatory's Very Large Telescope and New Technology Telescope. Star torn apart. Half falls in, half ejects. Light signature analyzed. Edelberger at Harvard Smithsonian confirms 1 million solar mass black hole. The ejected mass blocks light initially, then clears. The accretion disk brightens. We see the aftermath. Spaghettification documented. Not theoretical. Observed directly, spectrum analyzed, velocity measured, mass calculated, energy released, quantified, standard astrophysics applied to extreme event. The methods work. The results make sense. Theory and observation align. That's how science progresses. Theory predicts, observation confirms or refutes, theory refines, prediction improves, observation gets better, instruments upgrade. Repeat. Decades of this. Centuries for some fields, for black holes. 7 decades intensive work, starting from theoretical curiosity, ending in observed reality, hundreds of papers, thousands of scientists, millions of dollars invested, telescopes built, detectors designed, satellites launched, data archived, results published, knowledge accumulated, understanding deepens, strangeness revealed and embraced, because it's real, because the universe is strange, because black holes exist, because we can observe them, because the observations match predictions, because the predictions came from equations, because the equations describe reality, because reality includes objects where time stops and space tears and information might or might not escape, and tidal forces rip apart stars and rotation drags, space-time and horizons trap light and quantum effects, create radiation and mergers, produce gravitational waves, and we detect all of it. Measure all of it. Understand parts of it. Work on the rest. That's black holes. Much stranger than you imagine, but not stranger than they are. And what they are is documented, real, observed, measured, analyzed, published, tested, confirmed, year after year, discovery after discovery, each one strange, each one true, each one adding to the picture of a universe that doesn't care about human intuition, that just exists, strange, beautiful, terrifying, real. And we keep watching, keep measuring, keep discovering, because that's what astronomers do. We look up, we think hard, we calculate carefully, we observe precisely, and we document every number, every source, every date, every name, every measurement. Because strangeness requires rigor, claims require evidence, and black holes provide both. In abundance, forever strange, forever fascinating, forever real. Final data, archived at Berkeley. May 8th, 2025, Raffaella Margutti, UC Berkeley, Associate Professor, Physics and Astronomy. First time seeing massive black holes this close via tidal disruption events. The Wandering Hole, the Core Hole, same galaxy. Both active, both feeding. Separation 2,600 light years. Eventual merger inevitable. Timeline billions of years. But caught in progress. 2 holes, 1 system, both documented. Hubble images, Chandra data. Spectroscopic confirmation. The discovery stands, the implications extend, theory validated, observations continue. Science progresses, understanding deepens, strangeness remains, and we keep going. Because black holes don't stop being strange, they just become better documented, more thoroughly observed, more precisely measured, more completely understood, but still strange, always strange. That's their nature, that's their reality. That's what makes them fascinating. That's what makes them black holes.